So, we've all been promised these amazing AI assistants that can practically manage our entire lives. But here's the real question. Are they actually ready for the chaos of the real world? Well, some new research puts them through the ultimate test, and let me tell you, the answer is pretty humbling.
You've been there, right? I mean, we've all been there. You ask your super powerful AI to do something that seems pretty simple, like coordinate a meeting between a few people, and it just falls apart. They have access to pretty much all of human knowledge, but the second they have to act in our world, they just feel so brittle, so fragile. What is going on?
Well, according to the researchers behind this paper, the problem is how we're testing them. See, most AI benchmarks are totally static. The world inside the test only changes when the AI does something. It's basically like giving a teenager a driving test in a completely empty parking lot. Yeah, sure, they can prove they know how to turn the wheel and hit the brakes, but that tells you nothing about how they'll handle a world that's constantly moving on its own. Because let's face it, our world is messy. It's totally unpredictable. It's not an empty parking lot. It is rush hour traffic, with cars cutting you off, unexpected roadblocks, and new information flying at you every second. If we want AI agents to be truly useful, we have got to test them in an environment that fights back a little. And that is exactly what this new benchmark, called Gaia2, is all about. This isn't a parking lot. No, this is a full-blown military-grade obstacle course designed specifically for AI agents. It's built from the ground up to simulate the dynamic, ever-changing nature of our digital lives. So what's the secret sauce here? It's a concept called an asynchronous environment. And it sounds complicated, but the idea is actually super simple and kind of profound. It just means the world inside the test keeps moving forward, whether the AI does anything or not. New emails are going to arrive, meetings will get rescheduled, notifications pop up, all on their own timeline. Just like your phone does every single minute of every single day. And this is the engine that makes it all happen. It's called the ARE framework. Now, you can see the agent and the user doing their thing, interacting with the digital world. But the real magic, the key to this whole thing, is that event loop over on the right. That thing is always running, constantly injecting new, unexpected events into the system. It's what creates that rush hour feel, forcing the AI to react in real time, not just when it's convenient. Okay, so if you're going to build the world's toughest driving test for an AI, what skills do you actually need to measure? Well, Gaia2 breaks it all down into 7 critical challenges that an AI agent has to master if it ever wants to be considered truly capable. Let's just run through them real quick. It starts with the basics, right? Like execution, can it do the thing, and search. But then the difficulty ramps up fast. It tests if an AI can handle ambiguous instructions, if it can adapt when things change, if it can meet a hard deadline, and even if it can collaborate with other AIs. This thing is a serious workout for any agent out there. Let's zoom in on 2 of the hardest challenges because they're really interesting. First up, adaptability. So imagine your AI is in the middle of booking a meeting for you. Suddenly, an email comes in changing the time. Can it stop what it's doing and adjust on the fly? Then there's time, and this one is so crucial. Can your AI wait for exactly 3 minutes for a response before it decides to do something else? This tests both its patience and its ability to act with precise timing. It's way harder than it sounds. All right, the moment of truth. We have the ultimate AI driving test. The big question is, did anyone actually pass? The researchers put all the top large language models through the Gaia2 gauntlet, and the results? Oh boy, they are very revealing. The highest score that any model managed to get was just 42.1%. Let's just let that sink in for a second. In pretty much any school in the world, that is a big, fat failing grade. It just goes to show you how massive the gap still is between what our AIs can do today and what we actually need them to do in the real world. So here's a look at the leaderboard. You can see the high-end version of GPT-5 did come out on top, with Claude 4 Sonnet right behind it. But what the paper makes really, really clear is that no single model is the best at everything. They all have their own unique strengths and, as we're about to see, some pretty shocking weaknesses. And this is maybe the most important takeaway right here in this quote from the paper. The best performing model, the one that got the highest score overall, GPT-5 High, completely, and I mean completely, falls apart on one of those key challenges we were just talking about, time. And when I say completely, I'm not exaggerating. Just look at this chart. On your standard do the thing execution tasks, it gets a respectable 69%. Not bad. But on time-sensitive tasks, the ones that require it to act before a deadline, it scored a literal 0. A 0! It turns out being the smartest model often means it thinks for way too long, and it just misses the deadline. Every single time.
And this really gets to the heart of the problem that the researchers found. There's this fundamental trade-off, a constant battle between intelligence, cost, and speed. The most powerful models, the smartest ones like GPT-5 High, they also tend to be the slowest and most expensive to run. The faster models, well, they might be a little dumber or cost more. It's that classic problem, right? Intelligence, speed, cost. Pick two. The research also gives us a fascinating peek into the future. This here is an example from the agent-to-agent tests. In this scenario, the main AI isn't allowed to use tools directly. Instead, it has to send instructions to other, more specialized app agents and coordinate their actions to solve the problem. It's a really cool glimpse into a future where AI systems are going to have to work together in teams.
So, okay, we've seen the report card and it's not great. Why does a benchmark like this actually matter so much? Well, it's all about closing what developers call the sim-to-real gap. That massive chasm between what an AI can do in a sterile lab environment and what it can actually pull off in our chaotic world.
And this research gives us a crystal clear roadmap. Step one, by precisely identifying these weaknesses, like that total failure on time-sensitive tasks, we know exactly what we need to fix. That allows developers to move to step two, build better, more robust models. And that gets us to the ultimate goal, creating AI assistants that we can finally, actually trust to handle the messy, unpredictable nature of our lives. The paper's conclusion points to a really fascinating solution. It suggests that future AIs are going to need something called adaptive compute. In other words, they need to get smart about how they think. They need to learn when to use fast, cheap, lightweight reasoning for the easy stuff, and when to save that slow, deep, expensive deliberation for the really hard problems. It's not just about being smart, it's about being smart with your resources. And that really leaves us with one final big question. Right now, this test is incredibly difficult. The very best models are still getting a failing grade. But they're going to get better. They're going to improve. So you have to wonder, when an AI can finally score an A+ on this ultimate driving test, what kind of incredible new capabilities is that going to unlock for all of us?